Hello friends, my name is Shriprakash Singh and welcome back to our channel BI&DataScience.com. Today's video is second in a 5-part series that covers everything you need to master SQL from beginner to expert level. Now, if you haven't watched the first part, the link is here. It's also in the description. I definitely encourage you to go and watch that video after watching this video. In this video, we are going to talk about advanced filtering, where we'll also cover regular expressions, a very powerful technique to search any pattern in a string column, and we'll also cover aggregations. Covering aggregations, we'll talk about group by and the having clauses. Finally, we'll learn how to transform and create new set of columns or new set of informations from the existing columns in the table. So don't go anywhere. I'll be back after a very short intro. Friends, in today's video in advanced filtering, we are going to learn about in, not in, between, like, how to fetch null values, and how to work with regular expressions. So going back to our film table, in part 1, we learned about basic query. Say, I want to find all the movies that are rated PG. So my query would be select star from film where rating equals to PG. Now this gives me all the PG rated movies, right? All the movies that are PG rated. Now I also want to know all the movies that are PG-13 rated. So I want all the movies that are PG rated or PG-13 rated. So for that, we know we can use the OR operator, right? We can write that same query using OR. So that would be something like this. We'll say where rating is PG or rating is PG-13, right? Now you can see there is a repetition here. Here we are repeating. You see, we got the results. We got all the movies. Those are which are either PG or PG-13, but there is a neater way of writing this same thing. And if we have to write different many or conditions on the same column again and again, like if you're writing it on different columns, then it's okay to write OR. But if you're writing OR on the same column again and again, the neater way of writing that is using in. So what I can write is, I can write the same query as something like this. I'll say select star from film where rating is in PG-13, and then I'll comma separate it with the other value that I want. And if I wanted any other value, I can mention that also here. So if I wanted say NC-17, I can mention that also. So whatever value we want to be in the subset, we can specify all those values by a comma separated list, and then we can specify in. Now this will give me the same result. Now the good part is, when we can use in, we can also use not in. What that will give us is, that will give us all those movies that are not PG rated and also not PG-13 rated. So here I can say not in. See, we get the general and we get all the category except PG or PG-13. So this is the benefit of writing in or not in. In part 3 or 4, when we learn about join and subqueries, we will see additional use of this in operator. It becomes very powerful when we are trying to use it in combination with subqueries. But even without subqueries, you can use it in simple where clauses as well. Let's do the other using the word between. So for example, I want to find all the movies whose length is more than 1 hour but less than 2 hours. So I want to watch the movie having the length between 1 and 2 hours. So I can say that here, select star from film where length is between and we specify the starting value and ending value. So we said between, we said 1 hour, so that would be 60, and 2 hours, that would be 120. Now if we run this, we'll get all those movies which are more than an hour long but less than 2 hours. You see, we'll get all those movies which are more than 60 minutes and less than 120 minutes. When you use between clause, the important thing to remember is it will include the boundary values. So this 60 will be included and 120 will also be included. For example, let's write another query. So we want to find all those rentals which are between the 2005 May 26 and 2005 May 30. So we'll say where rental, the return date or the rental date, where the rental date is between say 2005 05 say 24, and I don't have to type the same thing again. So I'll just have to type here the end date. I don't have to type the column name again, right? So that's the benefit of using between. Here I'll say 2005 30, now 5 30. So this will give me all the rentals between these 5 days. 6 days from 24 to 30. You see, everything is between 24, 25, 26 and 30. Think of how I would write this query without using between. I would have to write that I have to write that like rental date is more than 2000 and rental date is less than this number. So you're typing more words. So just by using between, you can make your query neat and clean. So we learned in, not in, between. Now let's see how do we pull null values. Now pulling null value is tricky. So in this same rental table, think about there is a rental date on which the rental was taken by the customer, and return date is the date on which the customer is returning. Now there might be some customers who wouldn't have returned it at all. Like we want to send them reminders. So we want to find all those customers who do not have a return date. So in that case, the other way of saying is their return date is null. Null has two contexts. One, either it's unknown or it's undefined. In this case, it is defined. The return date is defined, but it is unknown. And the other case of null would be when you are asking something and that thing doesn't exist in the table. It will return null rows. That's called undefined. Whatever you are asking is not defined. You would be tempted to write something like this: select star from rental where the return date equals null, but this will not run. This will give an error because we cannot compare null with equality. We have to, there is an is operator, and we always compare null with is. So you see, we got all those data where the return date is null. So you saw for null, we do not use equality. Why? Because one unknown is not same as the other unknown. All the unknowns are different. That's why to compare unknowns, we do not use equality or inequality operator. We use the operator is null or is not null. So for example, if you want to filter all those records whose return date is not null, you have to say is not null. And you have to run this query. Now you get where all return date is not null. One big application of using is not null is many times when you want to join the table, you don't want to join another table on a table that has null in the join key. We'll talk about it in the coming series. Now let's learn doing more complicated filtering. These complicated filtering are mostly done on the text columns. For example, from the movie we had the title, right? Now in the title I want to find if the title contains action or love. I want to see only those movies. So how would I write this? Because the love and the adventure can come anywhere between the title. Let's say the first, let's see how the column looks like, right? So select star from film. Now if you run this, you see here the title is something like this. um, you have African Egg, Agent Truman, Airplane Sierra. So in this title, I want to find all those titles that have love or action inside them. So to do that, what I can do is there is an special operator called like. Select star from film. Again, we are filtering, so it will be inside where, and I have to filter the title. It would be title, and I'll say title like, and I'll say percent love. So this will pull all those titles that have love word inside the title. Let's see if we are finding anything. Yeah, the graffiti love, Idaho love, Indian love, Lawrence love, right? So there are some movies that has the word love inside it. By using the like operator, you can find anything that is embedded inside the value of a certain string column. And this can we can apply this on the description also. We can apply it on the special features also, like I want to find, say, all those title that have trailer as a special feature, right? So then I'll just have to say special features, special features like trailers, right? So now if I run it, you see all those special feature which has trailer inside it, we get all those movies. This becomes very handy when you are working with, say for example, in your customer table, I want to find all the customer whose email address is Gmail. Select star from now customer. Customer where email, like, I'll say percent gmail.com, right? Oh, we don't have anyone with Gmail. That's weird. Let's see all the records. Yeah, This is because I think most of the values are at the rate of sakilacustomer.org. That's why they are not having Gmail. But you got the idea, right? In like this percent is called wild character. Now it means anything. For example, when we filtered where title is like percent love, the title can contain anything before the word love, or when we say percent, it means it can contain anything after the word love, right? So probably we'll get little bit of more records than what we got last time. Yeah, you see. So we get all those title where there is something before love, and earlier when we ran we didn't got the lover Truman or the lover boy attack because we didn't filter for anything that is after the word love. So this person sign is called wildcard character. I want to find all those customers' name whose name has either A, E, I, O, U, any vowel in their name. I cannot write this kind of complicated query using like. So for this we use another very powerful operator, and this is called regular expressions. Now, if you can master writing regular expression, it is not only useful in SQL, but you can write regular expression on any string in Python also. The syntax is very similar. As you see on the next screen, for regular expressions, what we use is for finding any pattern, we use a dot. To find any word A, B, C, if you want to match something particular, you write it in the big bracket, and if you want anything other than this, then you write not ABC in the bracket. If you want any digit, you write /t. If you want any word character, you say /w. If you want any white space between the names, that's /s. If you want to put the condition in the beginning of the string, that would be not. If you want to use a condition for the end of the string, that is dollar, right? If you want something repeated for more than one time, you write asterisk. If you want it exactly n time, you can write n inside curly braces, right? You can write n inside curly braces. So this is a way of writing regular expression. Now this will come with a little bit of practice. So to write regular expression, you have to do a little bit of practice. For example, first let's find all those customers whose name has at least one vowel, where I can say first name is REGEX. Or let's find the customer whose name starts with a vowel. So to start anything, we write this symbol and we then say A, E, I, O, U, right? So this will give me the customer name whose name starts with vowel sound. We get all those customer names which is starting with a, we are getting all those customer names which are starting with a vowel like E, A, E, right? I. So this way we can write. Now we can also say whose name starts with a vowel and ends with a vowel. Then all I have to do is in the regular expression, you saw, right? What we can do is we can also put the condition for the end. We can do something like this. This is for starting with a vowel, and then for ending, we can have again A, E, I, O, U, and this time we can have $sign because that's for the end, right? Now this will give me all the customer whose name starts with a vowel and also ends with a vowel. See, Eva, it starts with E, ends with A, starts with A, starts with I, ends with A. So you can see like regular expressions are very powerful way of finding. So you can not only filter for name is starting with a vowel, ending with a vowel, but you can find all those occurrences where something occurs n number of times, or at least 5 times, at least 6 times, right? So in lot of cases, when you are tasked with finding complicated information, regular expressions are very handy, they are very powerful. Not every analyst is comfortable writing regular expression. So if you are one of those analysts who are very comfortable with writing regular expressions, that will give you an edge over a lot of other competitors. Now let's, for example, let's see one more use of this regular expression. So for example, let's say we want to find all those transactions who from the payment table whose payment was done on, say, exact 15th of the month, right? So first let's see the payment table, how it looks like. So what we can do is we can say select star from payment, right? Now you see this payment date, so this is happening on 5/25, 5/28, this is 6/15, 6/18, right? So they happen on different date. Now I want to find all those payments that are happening exactly on the 15th of the month. Now, and 15th of any month, it's very difficult to write it using like or any other wildcard character, right? So with regular expression we can do it easily. Select star from payment where, again we'll write on what column? Payment date. So we'll say payment date, and now we say regular expression, and in regular expression we say the beginning can be anything, so we'll put a dot for it, and then we know the 15th of month will have a dash before the 15th, so we say dash 15, and then we can say it can have anything after it. So let's run this. See, now we get all those payment dates, all those payments which are happening on the 15th of the month. Friends, why we are bringing one series in a week? Because after every training you have a week to download the software, do the hands-on practice, and that way you build your memory muscle. So it's a system. If you follow along with me for next 5 weeks, part 1 we already covered the fundamentals. You haven't watched, the link is here, go watch it. Part 2 we are covering today, and then we'll be covering other advanced stuff like joins and inner queries, sub queries. We will also be sharing all the materials, all the notes, along with some sample questions that you can practice on your own in the description. So follow along with me, and if you do everything, you watch all the videos and you do the hands-on exercise yourself, putting 2 to 3 hours a week, then I promise within a month you will be proficient in SQL. We covered the regular expressions. Now this is all that we wanted to cover in the filtering. Now let's look at the aggregations. What happens in aggregation? Think of aggregation as for certain rows you want to summarize the information, and most of the time the summarization of the information is done on either the numeric columns, or you want to find the count, like how many records are there in the table. Sometimes you also do the calculations on date field, like what's the minimum date, what's the minimum transaction date, maximum transaction date, right? So you want to find the min, max, average, sum, count. All these functions are called aggregate functions. For example, if we want to find in the film table how many total films are there, how many total movies are there, what I can say is I can say select count, and I want to count everything, so I can say count of star. Count star means just like select star means select everything. Count in star means count all the records from the table. Count star from film. Right? Simple. Let's see what this gives. So this gives you 1000. What it means is in the film table, there are record for 1000 films. There is a record for 1000 movies. Now, if I want to find just the count of how many ratings are there, how many unique ratings are there, right? What I can say is I can say select. Now to count distinct things, you have to use word distinct. You have to use the clause distinct. And distinct clause is always used with a column or a combination of column which you want to make distinct. For example, here I want to find the distinct ratings. So I can say select count distinct ratings from film. See, you have 5 ratings, 5 unique values for rating. And if you want to see those unique values, just like when you say select column from film, right? This will give me all the ratings for all the rows. So I will get 1000 values where PG will be repeated many times, PG-13 will be repeated many times. But I want only the distinct values. For that I can say select distinct. Rating from film. Now what this will give me is just the distinct values of the rating. So this way we can count everything. We can count occurrence of a particular column, values in that column. We can find the occurrence of unique values in that column. Now let's look at some examples for sum. So suppose I want to find the total payments made so far in the payments table. So what I can go is, and I can find select sum of amount from payment see, you get the payment. Now in the payment table we also had the payment date, right? So let's find the minimum value of the payment, the maximum value of the payment, the average value of the payment, and the total payment. So just like we found the total amount, we can also find a query. Like whenever you aggregate a field, by default the column heading for that aggregate function is the function itself, the aggregate function. So you see here the column name is sum amount. This is not very intuitive, and if I have to do many functions, it will become confusing. So what we can do is we can use the aliases, and aliases you can use the word as and you give a name, and that will become your column name when the output is presented to you. So I can say sum amount as total, and then I can say average. For that we use avg amount as average, and then I can say min amount as min payment, and then I can say max amount as see. Now we get the total payment $67,000. Average payment is $4.20. Minimum payment is $0. Maximum payment is $12. So you can use min max even on the date column to know the minimum date in that table, the maximum date in the table, and so on. So you can use all these aggregate functions in any way you can imagine. Now, because all this summary is happening at the whole table level, for now, when we are counting the sum, average, count, min, max, all the records in the table are considered. Now think of, I want to group the records. For example, in the film table where we have the rating, I want to find, say, the number of movies for each of the ratings. For example, for PG-13, how many movies were there? For PG category, how many movies were there? For G category, how many movies were there? If I want to find the count of movies for each category, this concept is called grouping. Grouping is when we are logically treating certain subset of rows as one group, and then we want the aggregate summary or aggregate value for some column for that particular group. That's called grouping. To find the total number of movies by each rating, we'll do the same thing. We'll say select. Now, because we want it for each rating as a rating, which is the grouping category as the column, we'll say rating. And because we want for each rating count of movies, so we say count star, because we want to count all the records, because this table is unique for each movie. So for every rating we want to find the unique movies, count star, and we can alias this as number of movie. Whenever you are giving column name, it has to be one word. You can make it intuitive name by using underscore, but don't use a space, because after a space it will be considered as some ID will consider as a separate column, but then you also have to specify the comma. Some ID will give error. MySQL will give you an error if you don't specify the comma. So you say rating count star as number of movie. Now let me type it. You can always write SQL on many lines. It's not necessary you write everything on one line. And for readability, a lot of time you'll see it writing like select, everything in select is part of one block. We write it on one or two lines separate. Then we write the from, everything on a new line, and then where on a new line. And now because we are going to do grouping, we'll type it on another line. So we'll say select rating, count of all the movies for each rating. Again, from this film table, we'll say from film. And now we say, we are not using any filtering, so we'll say we'll leave the where clause. But if you wanted the rating count of movies for each rating for a particular year, then that year condition would have gone in your where clause. But here we are not doing any where, so we skip where, but we now say group by, because I want this count to happen for every group of my rating. So if I run this, you see you see how this name becomes intuitive, number of movie. So for PG category I get 194 movies, for general category I get 178 movies, for restricted I get 195, and for PG-13 I get 223 movies. One of this video, in part 1 of our SQL, we had covered about what databases are, what are relational database versus NoSQL database, why you should learn SQL, similarity of SQL with algebraic expressions, how do you subset columns, how do you filter rows based on cell criteria or based on the logical operations at a row level using and, or, and not. And we also talked about order by and limit clauses. So if you want to learn all those, I highly recommend you watch this video. The link is in the description. Friends, if you're thinking of making your career as a business analyst or data analyst in 2025, and you're still wondering what all to study, in what order to study, and from where to study, then don't worry. we have created a comprehensive roadmap. We have covered all different tracks. And for all this career, what are the things that you need to learn and in what order and in what time you can learn them? We have compiled all those information in comprehensive roadmap. The roadmap document is free. The link is in the description. Go ahead, download, and we wish you a very bright future in 2025. So group by is very powerful when you want to get metric for different cuts of your data, for different slices of your data. This is similar to pivoting in Excel. How we pivot and we get the summary. We use aggregate functions for that particular group in SQL. The other example can be, say, for my this payment table. I want to get all these metric like the total payments, average payment. Let's ignore the min and max. We want the average and total payment, but now for each customer, right? We want it by customer, not by the total, but by all the customers. So I can say same thing. I can say select. Because I'm trying to get it for each customer, I'll have to use that grouping variable or grouping column in my select also. So I'll say select customer ID, comma, sum as total, average amount from payments, group by customer ID. That's it. Now I'll get how much each customer paid in total and the average payment by that customer over time, because I am grouping and aggregating everything. Now you can see customer ID 1 paid total $118 and his average payment was $3.70, $4.76, and total they paid $128. So they are renting quite frequently. So this is all about grouping. The important thing, why do we group a lot of time, is to also do additional filter on these aggregate variable. Remember, when we use where, when we try to filter the rows in the where clause, we are filtering based on a criteria that a cell value satisfies. And for different cell value criteria, we can combine those rows using logical operators of and or, but still all the calculation is happening at a cell level. I am not able to put any condition for that group level behavior. For example, in this case, in customer pay, for the payments table, I want to find all the customer who had paid us more than $100 in their lifetime. I want list of those customers. Maybe I want to call them high value customers. So for that, I could not have written this statement in the where clause, because when I say in where clause, select sum payment from table, that will do for the whole table. And if I don't sum, I only filter for customer where payment is more than 100, then no customer is paying $100 in one time, because on an average they are paying only $3 or $4, because they are renting one or two movie at a time. But I want to know all those customers who has paid me more than $100 over time. So for that case, first I have to group like this and find the total amount paid by the customers. And now I can filter it using another clause called having. So having is always used in conjunction with group by. And in having, you can only use the variables that you have used in your aggregated value. Only the values that you have aggregated, you can filter them in the having. You cannot filter any other value. So for example, here we have aggregated two variables, total and average amount. And because in having I have to specify a name, another important thing to note is always create the alias. Because if you, for example, if I want to filter having average amount more than something. If I don't give an alias for the average amount, I cannot reference it in the having, right? Now I can use a having either on the average transaction or on the total amount. So I can refer these columns here in the having. So I can say group by customer ID, having total more than $100, right? Now if I run, I'll only find like this customer ID 6 will go away, customer ID 8 will go away. Okay, see, now 6 and 8 are gone. So we only find all the customers who have paid more than $100 over their lifetime. So this is how we use group by and having. Having goes in conjunction with group by, and you use filter on the variables that you have aggregated for that group. You don't practice it a lot of time, you'll mix up your logic and you will write queries that are not accurate. Finally, cover the topic of transformation. Now transformation is nothing but creating new columns from the values of the existing columns. So these are also called as derived column. For example, here we have found the total amount paid by customer. Now I have so many customers. I want to know my average revenue for the total customers. For that, it's also called a metric called ARPU, revenue per user. If I want to find my revenue per user, what I can do is, because I have the total amount paid by all the users and I can do a count of all the users, then I can divide them together to get the revenue per user. So that query will look something like this. Select. So first I get the sum of all the amount, and then I divide it by the count of all the customers, which is nothing but all the unique records, all the records in that table. Actually no, let me show you this. I want to count it for the unique customers, because one customer would be doing transaction many times, right? And I want to know my average revenue per customer over the time, not the average transaction value. So I'll have to again say here distinct customer ID. So I'm counting my customer ID is 1. So I'm counting my unique customer ID and I'm doing a count of that, and this whole thing I'm calling as ARPU, revenue per user. ARPU is a very common metric. ARPU from payment. See, $112 is my ARPU. So my average revenue from each of my customer is $100 over their lifetime. Because I am deriving a new value by using a combination of value, so it is also a transformation of the aggregate values. Now many times you can do transformation of existing values, mostly on the string. You can change the case of your string columns, like your names, you can convert them to upper letters, uppercase, lowercase. You can strip the white spaces in the middle of a string, or you can concatenate two columns together to make one column, right? You can combine the values to make one, like if you have first name, last name separate, you can combine them together to make full name. So this is all transformation, because you are using existing column and you are applying some transformation on that, because I'm not aggregating, I will still get individual row level data, but I'm transforming it. For example, let's say customer. In customer table, we had the first name and the last name, right? Okay, so I have first name Mary, second name Smith. So they're all in capital letters. Now I want to change them to, maybe I want to change the first name to small letters and keep the last name as capital letter, and I want to combine them and call it as the full name. And I want full name of all my customers. So what I can do is I can do select. First let's write separate and then I'll show you how to combine them, because I want to make the concepts clear in your mind. So let's first select the first name, but I want the first name to be in lowercase. So I can say first name as lower. Lower is a function that will convert it to lowercase. Upper is the function that will convert it to uppercase. First name, lower first name, comma, last name, from customer. Now because I'm applying a function on this, it will change the column name, so I call it as L underscore F name, which means lower underscore first name. If I don't give it, you'll get the function name as the column heading, which is not very friendly, right? So I get you can see now this is converted to small case and this is uppercase. Now I want to concatenate them. So to concatenate, we have a function called concat. So I can say select concat Now I don't need this thing because it doesn't matter in the alias, it's just an argument. You see, I have a Mary Smith, but there is no space between the first name and the last name. So I can add one more argument here, and that argument can be space in middle. And then I can have the last name. So you see, I got first name. Okay, then I remove the lower thing. I can put the lower here. Alright. And I can put lower after concatenate. In that case, it will convert the whole thing as concatenate. Just like converting lowercase, uppercase, and concatenation, we also have replace. We can replace one part of a string with other part of string. For example, let's go here. In customer table, suppose this domain shakila-customer.org gets replaced. We got a new domain, or shakila.cust.org. If I have to replace that thing with the new domain, I can do it automatically by saying something like this. Let's say it will become select email as old email, right? And then what we are doing is we are replacing it. So we say replace email field, and within email field we want to replace the @ shakila-customer.org, @shakila.cust.org. right? As new email. So now you see, in every record, the Sakila customer.org is replaced with sakila.cust.org. So in this way, we can change any part of a string. We also have other complicated functions like substring. You can only extract certain number of characters starting from certain positions. You can look for the documentation, but the idea is this is how we transform variables at, you can transform the variables at row level. You can transform aggregate variables to create new derived values. Friends, so far in our part 2 of series, we covered advanced filtering. We learned new operators like in, not in, is null. We also learned how to use like and complex regular expressions. Then we learned about aggregation using the group by and having clauses. And finally, we learned about using transformations. So in part 3 of the video, we'll be learning more about the joins and subqueries coming up next week. So stay tuned, subscribe to the channel and hit that bell notification so that you get notified as soon as we publish the video. And please comment us what else you would like to learn in your SQL series. Happy learning, stay safe.